Alright, page 2 of section 1.2. And the next set of problems don't look like fractions, but we're really building more skills to be able to deal with fractions as we continue through this section. So wait it out here, you'll see how this is useful. The instructions say to identify each natural number as prime or composite. And if the number is composite, find its prime factorization. So a lot of vocabulary there. Let's kind of break that down. Natural numbers. We'll talk about these more as we move through this chapter, but for now, know that natural numbers refers to counting numbers. 1, 2, 3, 4, all the way to positive infinity, but the natural numbers are your counting numbers. So you aren't going to see any fractions or decimals here. Just nice, we might be tempted to call them whole numbers, but whole would include 0. We're not going to be seeing 0 in this case. So the counting numbers are the naturals. And then identify it as either prime or composite. So in terms of prime, it's only, what that means to be prime is it's only divisible by 1 and the number itself. So the number 3 is prime, because only 3 and 1 can go in evenly to 3. The number 7 is prime, 5 is prime, 9 is not prime because 3 goes into it, as well as 9 and 1. 11, 17, 13, 19, 23, the list goes on and on. In fact, there's people who've devoted their lives to finding the next prime number, and it's huge. It's pages and pages and pages long. It's fascinating. But I'm glad it's not my job. I like what I do much better. People. Anyway, and then 2 is prime. In fact, it's the only even number that's prime. And then there's the composite. And a composite number is essentially any number that's not prime, meaning it can be divided by something. And so what we want to do then is, how do you test if something is prime or not? If you've been exposed to these, great. If this is your first time, I think you'll really enjoy learning about these tools. They're called the divisibility rules. They're quick little tests to see if something is divisible by a particular number. And that will come in handy too as you try to find its prime factorization, which is a way to break it down all the way to its smallest things that can multiply to get you back to that original number. Some of you may have learned them as factor trees the first time you were exposed to this. But let's take a moment to look at the divisibility rules here. If something is divisible by 2, you can tell that right away if it's an even number. Or the last digit is divisible by 2. That's essentially what an even number means. Something is divisible by 3 if you add the digits together, digits meaning all the individual placeholders that make the number. In this case, 75, 7 plus 5 equals 12, and so that would be divisible by 3. So if you add the digits and that's divisible by 3, the entire number itself is divisible by 3. That is the divisibility rule for 3, or the check. Something is divisible by 4 if the last 2 digits are divisible by 4. And usually this is more helpful as the numbers get bigger. Triple digits, quadruple digits, 4-digit numbers. This comes in handy. The next one is, how do you tell if a number is divisible by 5? Well, it will either end in 5 or 0. And that's what makes it divisible by 5. 6 is 2 times 3. That's how you get 6. And so if it passes the divisibility test for 2 and 3, it will also be divisible by 6, because 6 is 2 times 3. So divisible by 2 and 3. So you have to pass 2 tests, and then you know that it is divisible by 6. Okay, so we'll note that passed both tests. Okay, there's no quick way to check for divisibility by 7, at least that I can remember off the top of my head. 8 last 3 digits are divisible by 8. And that's again for super duper huge numbers. That's really not something that we will encounter at this stage in the game for sure. Number is divisible by 9. It's very similar to the rule for 3. You're going to add the digits and then divide by 9, and if it goes in evenly, the whole number, the original number, is divisible by 9. And then finally, oh, I ran out of room, sorry, I'm going to squish it in here. Divisibility for 10 either ends, not either, it ends in 0 if it's divisible by 10. Okay. Alright, so let's look at how that comes into play here. So we're checking to see if this number is a prime or composite. So we just need to see if anything is divisible. We know it's not divisible by 2, it's not an even number. But let's check for 3. 7 plus 5, the 2 digits, equals 12, and 12 is divisible by 3, so this one is a composite because it's divisible by something. Composite. Whoops, I tried to throw an extra I in there. And now what we need to do is to find its prime factorization. So we need to break it down. We know it's divisible by 3, so we'll start there. 3 times what? 3 times 25. 3 is prime, so that's where we stop. Go and circle that with a different color. And then you want to see if 25 will break down. And just to follow the rules, I'm sure you know how to break down 25, but just to practice our divisibility. It's not even, so it's not divisible by 2. Add the digits. 2 plus 5 is 7. 7 is not divisible by 3. 4, last 2 digits. 25, is that divisible by 4? No. 5 ends in 5. Alright, in fact, it breaks into 5 times 5. So 3 times 25, 25 breaks into 5 times 5. 5 is prime, and as soon as you have everything circled and you can't go any further, you've come up with the prime factorization. In other words, it's another way to write the value 75 in its most basic elements. 75 is equal to 3 times 5 times 5. Let's look at number 24. It's 83. And is 83 even? No. Add the digits. 8 plus 3 is 11, not divisible by 3. Last 2 digits, is 4 going to 83 evenly? Nope. 5, does it end in 5 or 0? No, it's not divisible by 5. 6, it would have had to have passed both the 2 and 3, and it failed both of those, so it's not divisible by 6. 7, we'd have to check. 7 goes into 8 one time. Subtract, get a 1, bring the 3 down. 7 goes into 13 once with a remainder. Doesn't go in evenly. 8, last 3 digits, there aren't 3 digits, so it can't be divisible. It's not divisible by 8. And we know that by looking that it would either be 80 or 88 or something if it was divisible by 8. So we can rule that out. 9, let's add the digits. 8 plus 3 is 11. Still not divisible by 9 evenly. It's not divisible by 10, doesn't end in 0. Now there's tests for 11, 12, it would have to pass the test for 3 and 4, or 3 times 4 is 12, etc., etc. But this is plenty for our purposes. And you can keep trying all the way through, and then you will be convinced that 83 is prime. Now this is a typo here because I intended for number 22 here to be a try, so we're going to go ahead and make that change. Take a moment. Tell somebody or just yourself what you've seen here. Talk it through, copy it down, note any questions, bring those to your help resource or to class, and then pause the video so that you can give number 22 a try. Okay, hopefully you've had a chance to try 22. If not, hit that pause button right now because here comes the answer. It is a composite number. 110 is divisible by 2. Right there, you know that because it's even, it's a composite number. And its prime factorization, not fractorization, goodness sakes. prime factorization is going to be equal to 2 times 5 times 11. 2 times 5 times 11. Okay, and then page 16 in the book has some helpful reminders. What a composite number is and what a prime number is. And again, I try to say it in a way that makes sense to me. The book says it in a way that it makes sense to the author, and hopefully he's using, his hope is to expose you to the real technical and all the vocab and all that. So it's really great to kind of mix the two together, my style and the author's style, and then if you have an outside resource as well, they are going to have a style, and so it's good to kind of find your own way between all these different voices. Okay, we'll see you at the bottom of page 2.